Okay, Assalamualaikum. So now we will learn about the new chapter, which is chapter number 4, AC machine and drive. Okay, so the content of this chapter. So for this chapter, it is divided into 4 subtopics. So you will learn first about the introduction to the induction motor. Okay, we will do some revision on the induction motor, similar on what you have learned in previous semester. Okay, next we will look into the starting of induction motor. So the important to learn about this starting of induction motor is because the main problem of the induction motor is basically on the starting part. So the high current of the machine when the machine want to start. So by learning about the starting concept, so basically we can overcome the issue. Okay, next you will learn about the main subtopic on this chapter, okay, which is the speed control of induction motor. Okay, there are several techniques that will be discussed here. Okay, and then finally you will learn about the braking of induction motor, how to stop or to brake the motor. So I think this 4 subtopic is complete for the operation of induction motor. Okay, classification of AC motors. So basically AC motor can be divided into 2 main categories, which are synchronous motor and induction motor. So the synchronous motor is a motor that have the rotational speed of the stator, which is Ns, equal to the rotational speed of the rotor, which is Nr or Nm. So they don't have any slip speed or any difference in speed between Ns and Nr. So meaning to say Ns is always equal to Nr. So however, for induction motor, it's different compared to the synchronous motor. So the motor have some slip speed between Ns and Nr. So in this case, Nr is slightly less than Ns. So both motor have a single phase and 3-phase motor. So single phase is basically for domestic appliances, and 3-phase motor are used in high power application. An induction motor is a type of asynchronous AC motor where power is supplied to the rotating device by means of electromagnetic induction. So it means that there are no direct connection between the stator part and the rotor part. So the rotor get the supply by the concept of induction, similar concept as we have in transformer. So the analysis is quite similar to the concept of transformer. So the application of induction motor can be found in majority of our home appliances, fan, fridge, vacuum, and so on. So this is the image of an induction motor. So you can see that the 3-phase source will be connected at the terminal on the top of the machine. So meanwhile, the rotor part is basically the shaft placed inside the core of the stator. Okay, so for sure the most commonly motor used in industry is induction motor. Why? Okay, because simple in design, inexpensive compared to the other motor, high power to weight ratio, means that for a small induction motor, it can do more work due to the high power of the motor. Easy to maintain because this motor is quite rugged and also robust. And also this motor can directly be connected to AC power source. Okay, but induction motor also have some disadvantages. Okay, number 1, want to turn at constant speed, 50 Hz divided by half the number of pole, means that it is difficult to change the speed of an induction motor unless by using a proper speed control application. Okay, cannot turn faster than 1500 RPM for 4-pole motor. Okay, because based on the concept, so the rotor speed cannot exceed the synchronous speed. Okay, draw a massive starting current or is inefficient or both. So this is a typical problem for induction motor. So therefore we have to apply the starting technique for induction motor. Okay, last point is kind of big and bulky for the power is developed. So basically the size might slightly bigger for the motor that have the high capacity of power. Okay, so now we move to the components of an induction motor. So the basic construction for the induction motor consists of the rotor part and the stator part. So the rotor can be either squirrel cage or wound, located inside the core of the stator. So meanwhile, the stator is the outer part that's stamping with slot to carry the three-phase winding. So the stator of the motor is wound for a definite number of poles depending on the speed of the motor. Okay, so as you can see here, so this is the figure of the construction of a single phase and three-phase wound rotor of an induction motor. Okay, this is the figure of the motor used in washing machine. So on the left side is the stator and on the right side is the squirrel cage rotor. Okay, next, how induction motor works. So I think all of you have seen the video and already know the concept. But in simple explanation, so electricity will be supplied to the stator. Then the magnetic field generated from the stator will move around the rotor. Then the current will be induced in the rotor. So at the same time, the rotor will produce the second magnetic field that opposes the stator magnetic field. So finally, the rotor will begin to rotate. So for our syllabus, we will focus on the three-phase induction motor only. So the three-phase supply will be connected to the stator to produce the magnetic field. So the rotor can be either squirrel cage or wound, but the analysis is the same. So the induction motor is self-starting, so which means that the rotor will be energized without any source connected. Basically, the three-phase motor have high power capabilities and can be used in any industrial motor application. Okay, now we start to look into the parameter that will be used in the analysis of induction motor. So the concept of the rotor slip. So the voltage induced in the rotor bar of an induction motor depends on the speed of the rotor relative to the magnetic field. So if the speed of the rotor equal to the speed of the magnetic field on the stator side, so basically the voltage cannot be induced, means that no rotor current will produce in the rotor side. Two terms are commonly to use to define the relative relationship between the speed of magnetic field and the rotor speed. Number one, slip speed. So defined as the difference between synchronous speed and the rotor speed. Okay, and slip speed is equal to synchronous speed minus the rotor speed, where the slip speed is measured in RPM. Synchronous speed can be calculated using the equation of 120 F over P. And the rotor speed is the shaft speed of the motor in RPM. Okay, number two. So the slip is defined as the relative speed expressed on a per unit or sometimes as percentage basis. So slip is equal to slip speed divided by synchronous speed. Or in other form of equation, slip is equal to ns minus nr over ns. Notice, if the rotor turns at synchronous speed, slip is equal to 0. Why? Because ns minus nr will be 0. While if the rotor is stationary or standstill, slip is equal to 1, because the rotor speed now is 0. So mechanical speed or the rotor speed can be expressed in terms of synchronous speed and slip as below. So nr or nm is equal to ns multiplied by 1 minus s, or omega m or omega r is equal to omega s multiplied by 1 minus s.